Hello. In this video, we're going to look at one more type of transformation, this time a reflection. So let's take the following function, x minus 1 squared plus 2, and we're going to graph the transformation y equals negative fx. Now I've gone ahead and graphed the function here with Desmos so we can see, because of the square we have a parabola shape, so we can see that nice parabola shape. The minus 1 means the vertex is over here at positive 1 on the x, and the plus 2 means the vertex is at plus 2 on the y. So we can actually see we've got some nice points here. This is going to be at 1 and 2. This point over here is at 2 and 3. And this point is at 0 and 3. Those are going to be important once we do the transformation. Now, the equation says y equals negative fx. In words, what that means, if we were to translate this to English, is it means we want to do a vertical reflection. It's vertical because that negative is in the same place you'd have a vertical stretch. And just as a bit of a heads up, if you want to do a horizontal reflection, you'd have to have that negative next to the x. Here, because it's outside the brackets, we're dealing with the y values, not the x values. All right, so what are we going to do to the y values? Well, visually, we want to take this graph and we want to reflect it down here. So that's going to require us to take the y values and make them negative. If we do the mapping, we have our points 0, 3, 1, 2, and 2, 3. And we're going to take each one of those points, and we're going to take the y value, and we're going to make it negative. Well, technically, we're going to multiply it by a negative 1, but in this case, because they're all positive, we're going to make them all negative. So this becomes 0, negative 3. This becomes 1, negative 2. This becomes 2, negative 3. Now we take those new points. They don't quite fit on our graph, so we'll have to move this up a little bit. Take those points, and we go ahead and graph them on our grid. Connect the dots. And we have ourselves a vertical reflection. Again, you can see visually how we've taken this graph and we've reflected it down to this graph. Now, in terms of the vertical reflection, if you notice, the location of the reflection happens right here. You can imagine this line right here, sort of like the mirror, or it's the axis where the reflection is occurring. We didn't just take this graph and reflect it down like this. We actually took the graph and we reflected it across the x-axis. So you could say it's a vertical reflection. That's one way of writing it in English. Or another way of writing it is you could say we have a reflection across the x-axis. All right. What if we were to do the other one? Y equals f of negative x. Well, again, in this case, because the negative is next to the x, we're not dealing with a vertical reflection. We are dealing with a horizontal reflection. So that means that we take our initial points here. I think they're the same. It looks like 0, 3, 1, and 2, and 2 and 3, same base graph. And now we're going to take the x values, and we're going to multiply them by negative 1, or in other words, make them negative. So we would get 0, negative 0 is just still 0, negative 1, negative 2. The y values remain the same. So if we were to graph that, we'd have 0 and 3 is still there, negative 1 and 2, negative 2 and 3, and we would go ahead and connect the dots. So you can see here that if you imagine a line right here, this line is kind of the mirror, and you can see that the two graphs are mirror images of each other across this line. So we could call it a horizontal reflection. Or if you wanted to use different language, you could say it's a reflection across the y-axis. I know the terminology is a little weird. A horizontal reflection reflects across the y-axis, and a vertical reflection is across the x-axis. It's kind of backwards. You'd almost expect the horizontal reflection, because we're talking horizontal, to do the x-axis. But when you write it out in the English, you see that even though we're reflecting the x values, the line or the mirror that we draw is actually the y-axis. So just a bit of terminology there to watch for. Now, of course, we could do both transformations at the same time. We could do a vertical reflection and a horizontal reflection. So here we have a graph with some points, 3, -6, 5, -4, 8, -4, and 11, -1. So go ahead and take those points, map them, make sure you take the y values and multiply by -1, take the x values and multiply by -1, or you can think of it as flipping the sign, and see what you get for your new points. I'd encourage you to pause the video and give it a try. All right, so assuming you gave this a try, this should become -3 and 6. This point here is going to become -5 and 4. This point is going to become -8 and 4. And this will become -11 and 1. So to sketch that, I'm probably going to actually have to draw a new set of axes over here, just because I don't think it's going to be actually in that quadrant, down in the bottom right quadrant. When I start to put these points on a graph, -3 and 6, well, that's going to be, let me just see my scale. -3 and maybe 6. It's going to be kind of up here. Then I have -5 and 4. Then I'm going to have -8 and 4. Then I'm going to have -11. Let me just extend this a little bit further. -11 and 1. Again, connect the dots in the same order you draw them. And that is our new shape. It's been reflected both vertically and horizontally. All right, so this was a nice short lesson. The basic thing we learned was reflections, which are a type of transformation. And if you have y equals -fx, this is a vertical reflection. If you have y equals f of -x, this is a horizontal reflection. And the way you do it is you just flip the sign, or you flip a sign, or you can think about it as multiply by -1. You multiply by -1. So point -3 and -10, if you were to do both of them, becomes 3 and +10. Now, over here for your example, you can go ahead and choose one. We're working on Unit 2, Worksheet 9. So just go ahead and choose an example from there, and you can finish it off in your notes. Hopefully you enjoyed this video, and as always, thanks for watching.